Okay, so good afternoon to one and all. In the previous lecture of electrical machine first, we have discussed regarding one point is that the back EMF and significance of back EMF. I think this point we have covered in the previous lecture. Can anyone tell me what is meant by back EMF? Anyone?
When armature is rotating,
okay.
then back EMF.
Okay. When armature of the DC motor, it will start rotating. Then according to the principle of electromagnetic induction, or according to the principle of Faraday's law of electromagnetic induction, there is a some of the EMF it will be induces in the armature of the motor. So this EMF it will be act opposite to that of supply voltage, so that we can call it as a back EMF, or we can call it as a counter EMF. Okay. So when armature of the motor it will be start rotating like that, the back EMF of the motor it will be start developing. Okay. So tell me at a standstill condition, what is the value of back EMF? When the motor is at standstill condition or the stop condition, what is the value of back EMF?
Equal to supply voltage.
Again there is confusion. I am telling regarding at a standstill condition, or when the motor is at a stop condition, or it may be standstill condition. What is the value of back EMF? We are telling when armature of the motor start rotating, then back EMF it will be developed. ज्यावेळेस मोटरचा आर्मेचर रोटेट व्हायला स्टार्ट होईल त्यावेळेस बॅक ईएमएफ डेव्हलप होतोय आपण सांगतोय. मी सांगतोय मोटर स्टँडस्टिल कंडिशनला आहे किंवा स्टॉप कंडिशनला आहे. व्हॉट इज द व्हॅल्यू ऑफ बॅक ईएमएफ? Zero. No, at standstill condition the back EMF of the motor it will be zero. This is MCQ question. When armature of the motor it will be start rotating, ज्यावेळेस मोटरचा आर्मेचर रोटेट व्हायला स्टार्ट होईल, रोटेट ज्यावेळेस होईल म्हणजे मेकॅनिकल इनपुट मिळेल त्यावेळेसच EMF इंड्यूस होणार आहे ऍज पर द प्रिन्सिपल ऑफ इलेक्ट्रोमॅग्नेटिक इंडक्शन. So when armature of the motor it will be start rotating, then EMF, that is back EMF, it will be developed in that of armature. So according to this, there is a first one significance is that, याच्यावरून एक पहिला significance आहे, when motor is running on no load condition. मोटर ज्यावेळेस नो लोड कंडिशनला रन होते, that means it is running on constant speed. What is the value of back EMF?
Equal to supply voltage.
Nearly equal to supply voltage. Okay, so just understand the difference between that standstill condition and normal running, or it may be on no load condition running. म्हणजे रन होते नो लोड कंडिशनला रन होते म्हटल्यानंतर मिनिमम लॉसेस असतील, त्याच्यावरती लोड नाहीये. So at that situation the back EMF of the motor it is nearly equal to supply voltage. So the current taken from the armature it is very small. It is only required to overcome the no load losses. Okay, so this is first one significance. Similarly second one significance होता when the load on the motor it will be suddenly increases. ज्यावेळेस मोटरचा लोड सडनली काय करतोय आपण इन्क्रीज करतोय. First effect is that the armature of the motor it will be slowing down. ते हळूहळू स्लो व्हायला स्टार्ट होईल. Okay, so armature of the motor it will be slowing down. If the armature of the motor it will be slowing down and load increases, that means current taken from the supply it will be increases. Okay, so or the torque requirement it will be increases. If the torque requirement increases, to develop that much amount of torque, the motor take increased amount of current from the supply. मोटर काय करेल, सप्लाय कडून increased amount of current काय करेल, घेईल. Okay, so this is nothing but we can call it as a self regulating machine. म्हणजे जेवढा टॉर्क डेव्हलप करण्यासाठी करंट रिक्वायर्ड आहे तेवढाच करंट मोटर काय करेल, सप्लाय कडून घेईल. टॉर्क रिक्वायरमेंट कमी झाली म्हणजे लोड कमी झाला की टॉर्क कमी होईल. टॉर्क कमी झाला की करंट टेकन फ्रॉम द सप्लाय इट विल ऑल्सो रिड्यूसेस. And opposite to that, when the load on the motor it is suddenly decreases, मोटरचा लोड जर आपण सडनली डिक्रीज केला, फर्स्ट इफेक्ट इज दॅट मोटर स्टार्ट ऍक्सेलरेटिंग, म्हणजे त्याचं जे काही स्पीड आहे ते रेटेड स्पीड पेक्षा जास्त स्पीडनं मोटर रन व्हायला लागेल. ओके, or the motor it will be start rotating. So if the motor it will be start rotating, that means the back EMF it is also increasing, and this increased back EMF it will allow to flow the current from the supply, that is reduce the current from the supply. Current काय will supply कडला reduced होईल, and current it will be reduces up to when motor stop accelerating. जोपर्यंत मोटर ऍक्सेलरेट व्हायची स्टॉप होत नाहीये, म्हणजे टॉर्कला सफिशियंट करंट जोपर्यंत सप्लाय कडून मिळत नाहीये तोपर्यंत मोटर ऍक्सेलरेट व्हायची स्टॉप होत नाहीये. अँड वन्स द करंट टेकन फ्रॉम द सप्लाय इट विल बी जस्ट सफिशियंट टू डेव्हलप द रिक्वायर्ड अमाउंट ऑफ टॉर्क which is required by the load, then the motor it will be stop accelerating. So these are the three significance we have discussed in the previous lecture, and we have discussed the concept of back EMF in the previous lecture. Today we will discuss about the next one important point, is that the torque equation. Again it is one little bit derivation, and it is very important derivation. It is useful while solving a problem also, as well as it is useful while deriving the characteristics of DC motor also. Okay, so that is the point, is that the torque equation of the DC motor. Okay, torque equation of DC motor. DC motor च torque equation आपल्याला derive करायचं. So first of all we will discuss what is mean by torque, how it can be derived, and we will derive the torque equation. Okay, see, before deriving the torque equation, first of all we will derive the output power equation, and once output power equation it will be derived, then we are able to derive the torque equation. Okay, see, the important point is that the torque equation, this is important question, derive and torque equation. This question it will be always asked in the university examination. Derive the torque equation of DC motor, or it may be derive the torque equation, असा question असेल. So torque equation, torque equation. So see, what is meant by torque? First of all, torque it is nothing but it is the turning or the twisting movement of the force, or the torque it is nothing but it is the turning or the twisting movement of the force around its own axis. Torque means what? All of you understand the definition. It is a turning or twisting moment. एखादा object आहे, suppose one object is there. I will draw here one of the object is there. Suppose this one is the object. This object, what is mean by torque? I am telling definition of the torque. Torque is nothing but it is the turning or the twisting movement. ह्या ऑब्जेक्ट टर्न होण्याची किंवा ट्विस्ट होण्याची जी काही मुवमेंट असेल about its own axis, about its own axis, due to the force applied on that object. ज्यावेळेस त्या ऑब्जेक्ट वरती फोर्स अप्लाय केला जाईल त्यावेळेस तो ऑब्जेक्ट काय करेल, त्याची पोझिशन चेंज करेल ना. And it will be start rotating about its own axis. Suppose the object it is circular. If we have taking the object, it is a flat surface. Suppose we have taken here one object is nothing but stone घेतला आपण, stone. If we apply the force to that of stone, then the stone movement or the stone it will be moves from their position. Okay, so this is torque is nothing but in case of motor, torque is nothing but it is the turning or twisting force or turning or twisting movement. टर्न होण्याची किंवा ट्विस्ट होण्याची जी काही मुवमेंट असेल, इट इज नथिंग बट टॉर्क. अँड हाऊ इट विल बी टर्न? वेन द फोर्स इट विल बी अप्लाइड. कशामुळे ते टर्न होईल? ज्यावेळेस फोर्स अप्लाय केला तरच टर्न होईल. So according to the definition is that the torque it can be defined as it is the turning or the twisting movement of the force about its own axis, म्हणजे त्याच्या ऍक्सिस भोवती त्याची जी काही टर्न होण्याची किंवा ट्विस्ट होण्याची मुवमेंट असेल ड्यू टू फोर्स. सो दिस मुवमेंट इट इज कॉल्ड एज टॉर्क. Okay, now this value of this torque, it can be represented by, if we are considering in case of motor, the value of torque, it can be measured by force into radius of that means movement or radius of that object. See, एखादा ऑब्जेक्ट आहे, हा ऑब्जेक्ट मी जर मूव केला किंवा फोर्स अप्लाय केला, फोर्स अप्लाय टू दॅट ऑफ ऑब्जेक्ट इज नथिंग बट हॅव्हिंग एन व्हॅल्यू एफ and it will be complete its one cycle having an radius of that object is nothing but r. So the torque, it can be measured, torque, it is measured, torque, it is measured by the product of force, that means applied force into radius of that object, radius of that object at which it will act. ज्या ठिकाणी फोर्स अप्लाय झालेला आहे किंवा ज्या ऑब्जेक्ट वरती फोर्स अप्लाय झालेला आहे त्या ऑब्जेक्टची त्याच्या सेंटर पासून जी काही रेडियस असेल, सो रेडियस ऑफ दॅट ऑब्जेक्ट at the force applied to that of object, ज्या पॉइंटला फोर्स अप्लाय झालेला आहे, so that force and the radius of that object, it is nothing but the torque. So according to this, we are defining the equation torque T is equals to force F into R, force F into R, right? No, here we have defined the equation of torque is that torque T is equals to force into the radius of that or the radius at which the force it can be applied. जिथं फोर्स अप्लाय केलाय तिथून त्याच्या सेंटर पर्यंतची डिस्टन्स किंवा सेंटर पर्यंतची जी काही रेडियस असेल, इट इज नथिंग बट टॉर्क. सो दिस इज द डेफिनेशन आय हॅव टेल. नाउ सी, to derive the torque equation, first of all consider one of the drum or the pulley. So the drum or the pulley of the motor, मोटरचं जे काय मेकॅनिकल आउटपुट आहे त्याला आपण ड्रम अप्लाय केलंय असं कन्सिडर करा. That is, consider a pulley or it may be drum. I will draw a same diagram here. See, consider one of the rotating drum or one of the pulley which is attached to that of shaft of the motor. मोटरच्या shaftला एक drum किंवा pulley attach केले. Okay, so see, this is the shaft of the motor, this one is the pulley of the motor, and here it is central line. The force F, it can be acted on that of one point of the pulley. याच्या one point ला काय झालेलं आहे, force act झालेलं आहे. The radius of that pulley, it is nothing but it is equals to R, and this, when the motor it will be start rotating, this will be rotating by a speed that is n revolution per second. Okay, so हा जो काही ड्रम आहे किंवा पुली आहे, it will be start rotating by a n revolution per second, that is RPS. Okay, so speed of that pulley, consider one of the pulley having a radius r meter, and the force it can be acted on the circumference of that pulley. त्या पुलीच्या circumference वरती force act झालेला आहे. And do you know that the unit of force is nothing but Newton, and it will cause the rotation of that drum or the rotation of the pulley. त्याच्यामुळे पुलीचं रोटेशन होतंय किंवा ड्रम रोटेट होतोय, having an speed of that rotation, it is nothing but n revolution per second. Okay, so that means n number of revolution it can be done due to that of force having an n revolution per second. So according to this, we are according to definition of the torque, we are defining the equation torque T is equals to applied force into radius of that drum or it may be radius of pulley. Pulley ची radius किंवा drum ची radius. Okay, so see, we have discussed that drum radius and the force applied to the top drum. So the torque it can be defined by torque T is equals to force into radius. So unit, what is the unit of force? Force unit काय आहे? फोर्सचं युनिट ऑफ फोर्स
न्यूटन.
न्यूटन. And radius, unit of radius,
मीटर.
hello, unit of radius, meter. Okay, so see, the unit of force is nothing but Newton and the unit of radius is nothing but meter. So the unit of torque, it is nothing but Newton meter, right? No, unit torque unit काय येतं? Newton meter. I think you people already know. Now we have defined the equation, that is torque T is equals to force into radius, that is F into R. It is in Newton meter. Suppose we have represented this equation number 1. Now how much work done it can be done due to that force in one complete revolution that we want to represent. That means I want to represent the work done by the force in one revolution. सी फोर्स काय करतोय, तो ड्रम रोटेट करतोय, राइट? ड्रम कुठं रोटेट होतोय, त्याच्या ओन ऍक्सिसला रोटेट होतोय. अकॉर्डिंग टू वी हॅव रिप्रेझेंटेड द इक्वेशन टॉर्क टी इज इक्वल्स टू एफ इंटू आर, राइट? नाउ at how much work done it can be done due to that force when it will be complete one revolution. ज्यावेळेस या फोर्स न हा ड्रम एक रिव्होल्यूशनचं कंप्लीट केला किंवा एक इथं जर ऑब्जेक्ट कन्सिडर केला किंवा इथे एक पॉइंट कन्सिडर केला, हा जर रोटेट होऊन परत या पोझिशनला आला म्हणजे वन रिव्होल्यूशन कंप्लीट झालं, राइट?
येस सर.
Okay, so see, we want to represent the work done by that force in one complete revolution. एका revolution मध्ये किती वर्क कंप्लीट झालं? What is the formula for that? बघा, एक ऑब्जेक्ट घेतो मी इथं. सपोज हा डस्टर आहे, or it may be one of the object is there. If I apply somewhat force on that object, ऑब्जेक्टची ही पोझिशन आहे, याच्यावरती मी काहीतरी फोर्स अप्लाय केला आणि या पोझिशन पासून मी ऑब्जेक्ट या पोझिशन पर्यंत मूव्ह केला. ओके, ड्यू टू दॅट फोर्स द ऑब्जेक्ट इट कॅन बी मूव्ड फ्रॉम दिस पोझिशन टू दिस पोझिशन. ओके, इथून इथपर्यंत मूव्ह केला. ऑब्जेक्ट काय झाला, फोर्स अप्लाय केल्यामुळे तो ऑब्जेक्ट मूव्ह झाला. इथं मी लिनियर मोशन घेतोय. इथं ही जी काही डायग्राम ड्रॉ केली आहे ती रोटेशनल मोशनची. लक्षात घ्या, दिस वन इज द linear motion, this one is the rotational motion. If the force it can be applied to the top object, it will cover a sum of the distance. Okay, so see, it will cover a sum of the distance. When it will cover a sum of the distance, then work done by that force, त्या force ने किती वर्क डन केलं कसं सांगू शकतो आपण? What is the formula for that?
Force into displacement.
Right. So work done by that force, it is nothing but applied force. म्हणजे किती फोर्स अप्लाय केला होता आणि त्याने किती डिस्टन्स कव्हर केले, इट इज नथिंग बट वर्क डन, राईट? नो, म्हणजे मी 1 किलोमीटर पळालोय म्हणजे 1 किलोमीटर हे काय झालं, माझं डिस्टन्स झालं. आणि किती फोर्सने किंवा किती स्पीडने पळालो होतो हे माझं काय झालं, फोर्स झालं. सो दॅट मीन्स द वर्क डन बाय द फोर्स इन वन रिव्होल्यूशन, इट इज इक्वल्स टू work done by the force in one revolution. It is equals to, the formula for that is nothing but the force into distance, or it may be displacement, distance traveled. त्या फोर्स ने किती डिस्टन्स ट्रॅव्हल केलं, किती डिस्टन्स ट्रॅव्हल केलंय इन वन रिव्होल्यूशन? एका रिव्होल्यूशन मध्ये किती डिस्टन्स ट्रॅव्हल केलं फोर्स न? एक सायकल कंप्लीट केली ना, एक राऊंड कंप्लीट केलंय. हो, काय लिहितो आपण त्याला? व्हॉट इज द पेरिमीटर ऑफ दॅट सर्कम्फरन्स? काय फॉर्म्युला? Okay, see, the work done by the force, it is equals to force into distance. So applied force as it is, and work done in one revolution, एका revolution मध्ये त्यानं केलेलं जे काही वर्क असेल, it is nothing but one revolution. One revolution is nothing but perimeter of that circle. Circle चा perimeter काय फॉर्म्युला? 2 pi r. Right? No, that means the work done by the force in one revolution, it is nothing but the applied force F into 2 pi r. What is the unit of work done? Work done से unit क्या है? Unit of work?
Joule.
Joule. Okay. Unit of work done, it is equals to joule. So this is equation second. Now see, all of you understand the concept. I have defined the torque. Torque define केला. Torque is equals to F into R. Then I have considered one pulley having an R radius, and the force F it can be applied on that pulley. So how much work done it can be developed, or how much work it can be covered in one revolution, that I have represented force into perimeter of that circle or the perimeter of that pulley, that is 2 pi r. Okay, now it is equals to joule. It is equals to joule. Now consider there n number of revolution. आता आपण एका revolution साठी consider केलेलं आहे. So there are n number of revolution is there. Number of revolution काय आहेत? n आहेत. It is in second. So that we can represent the work done, or it may be at that point the power developed. Power developed. Power developed, it is equals to work done in one revolution, and if n number of revolution is there, so that we can write here force F into 2 pi r into n number of revolution. N number of revolution. So power developed चे unit काय होईल? Joule. Number of revolution RPS मध्ये speed घेतलेलं आहे, so joule per second, or we can write it as a power developed, it is in watt. Okay, so see, जर ते n नंबर फिरला असेल किंवा n नंबर ऑफ रोटेशन घेतले असतील, तर टोटल पॉवर डेव्हलप्ड इन दॅट आर्मेचर or the total power developed in the top object, it is equals to force into 2 pi r एकाचा into n number of revolution. So n number of revolution per second. Okay, RPS, that is revolution per second म्हटलेलं आहे. Unit येईल joule per second. So joule per second, it is nothing but watt. Okay, so this is the power developed. Now we rearrange this equation, that is power developed or power, it is equals to F into R, F into R into 2 pi n. Rearrange केलं फक्त मी. F into R into 2 pi n, it is in watt. What is mean by F into R? What is F into R?
Torque.
Power developed, F into R is nothing but torque. So I can put here torque T into 2 pi n. Torque T into 2 pi n. Where if we consider here 2 pi n is the linear motion, if we consider the angular motion, instead of representing 2 pi n, we are able to represent the omega also. So that the power developed इक्वेशन हे तुम्हाला प्रॉब्लेम सॉल्व करताना लक्ष म्हणजे प्रॉब्लेम सॉल्व करताना यूज होणार आहेत. ऑल ऑफ यू नोट डाउन दिस इक्वेशन. See, instead of representing 2 pi n, can I represent omega also? Omega is nothing but angular velocity. It is in radian per second. So that we can write equation, that is power developed, it is equals to torque into omega. Omega is nothing but 2 pi n, right? No, omega it is nothing but 2 pi n. and the unit of that, it is nothing but watt. So that much amount of power it can be developed, that much amount of power it can be developed in case of that rotating object, or it may be in case of that pulley or the object or armature. Okay, now see, see, initially I have tell before discussing regarding torque equation, or the before deriving torque equation, we will derive the power equation. आता मी power equation derive केले. Suppose the speed of the motor, it can be taken in revolution per minute, that is rpm. rpm मध्ये represent करायचं असेल तर n divided by 60 येईल. Okay, so power developed, or the speed, if speed it is taken in revolution per minute. revolution per minute मध्ये घ्यायचं असेल तर डिवाइड बाय 60, n divided by 60. So that the power developed equation, it is equals to 2 pi n t. बघा 2 pi n आणि t आहे. स्पीड आपण revolution per minute मध्ये घेतोय, so that divide by 60. So this is the equation, that is power developed in case of DC motor, it is equals to 2 pi nt divided by 60. I think this equation we have used in the practical while doing the calculation or while finding the power output calculation. P out चे calculation करताना आपण यूज केले का इक्वेशन हे? लोड टेस्ट जी आपण जी काय प्रॅक्टिकल घेतले लोड टेस्टचं यूज केलंय ना?
Yes, sir.
Okay, so see the power developed equation. First of all of you write the power developed equation, that is 2 pi nt divided by 60. 2 pi nt divided by 60. Here 2 pi it is the constant, n is nothing but the speed of the motor, and t is nothing but the torque of the motor. मोटरचा टॉर्क आहे आणि n is nothing but speed of the motor. It is in revolution per minute. मिनिट मध्ये घेतलंय. जर सेकंद मध्ये घेत असाल तर डिवाइड बाय 60 येणार नाही. ओके, सो 2 pi nt फक्त. Generally we are representing it is in revolution per minute, so we have taken the equation 2 pi nt divided by 60. So this is the power developed equation. If we rearrange this equation, again जर rearrange केलं equation, तर हे equation आपण असेही represent करू शकतो. 2 pi divided by 60 किती येते बघा, आणि 1 divided by, that means we can represent, that is nt divided by 9.55. nt divided by 9.55, it is nothing but power developed. It is nothing but power developed. Now from this power developed equation we want to derive the actual torque equation of DC motor. आपल्याला याच्यावरून DC मोटरचं actual torque equation काय करायचं, derive करायचं. ओके, इथपर्यंत समजले का? इज देयर एनी डाऊट? कुणाला काही डाऊट आहे का याच्यामध्ये? हॅलो, इथपर्यंत कोणाला काही डाऊट आहे का?
No, sir.
Okay, can we move for torque equation? Actual torque
Yes,
equation
sir.
of DC motor. Okay, I will rub this left hand side. Okay, so we will deriving the torque equation. Now we will deriving the actual torque equation of the DC motor. Okay, now see, let the torque TA, T suffix A, torque TA be the torque developed, torque TA be the torque developed by the armature of the motor by the armature of the motor running at n revolution per second. Okay, see, we have considering the torque, that is armature torque TA be the torque developed in the armature of the motor. मोटरच्या आर्मेचर मध्ये डेव्हलप होणारा टॉर्क TA आहे असं कन्सिडर केलं. when the motor it can be running in n revolution per second. when the motor it can be running in the n revolution per second. Okay, okay, so if we are considering the torque TA, so if torque TA it is equals to, or the TA it is in Newton meter, TA it is in Newton meter, then we write the equation, the power developed in the armature, power developed in the armature, power developed in the armature. What is the formula for power developed in the armature? When the motor it can be running in n revolution per second and the torque of the motor it is TA. What is the formula? काय formula? क्वेश्चन लक्षात आलं का माझं? Power developed in the armature of the motor when the speed of the motor it is n revolution per second and the torque of the motor it is TA or armature torque TA. Power developed चा formula काय? काय फॉर्म्युला समोर आहे ना तुमच्या? पॉवर डेव्हलप्ड इज इक्वल्स टू 2 पाय NT बाय 60. कधी 60 येईल? 60 ज्यावेळेस स्पीड रिव्होल्यूशन पर मिनिट मध्ये असेल. वी हॅव टेकन स्पीड रिव्होल्यूशन पर सेकंड, सो दॅट द इक्वेशन that is 2 pi n into t. Instead of representing t, we are representing TA, that is armature torque TA. This is equation 1. See, we are considering the torque TA, that is armature torque TA. So the torque developed in the armature when the armature of the motor it will be rotating n revolution per second and TA be the armature torque. Then the power developed in the armature it is equals to 2 pi n TA. It is the equation first. Okay, it is the equation first. Now another one point is that we also know that we know that the electrical power developed in the armature of the DC machine, armature of the DC motor is electrical power developed in the armature of the machine. What is the formula for that? That is P developed in the armature. P armature. This one is also P armature. Power developed in the armature of the DC machine किंवा DC motor. DC मोटरच्या आर्मेचर मध्ये इलेक्ट्रिकल पॉवर डेव्हलप होणारी काय फॉर्म्युला त्याचा? क्लू देऊ का?
V into IA.
फी इंटू IA. फी आहे का EB आहे? फी वेगळा आहे, EB वेगळा आहे. फी इज नथिंग बट टर्मिनल व्होल्टेज, EB इज नथिंग बट बॅक EMF. त्याच्यामध्ये डिफरन्स आहे. आपण व्होल्टेज इक्वेशन मध्ये त्याच्या काय म्हणतो आपण इम्पिडन्स ड्रॉपचा डिफरन्स आहे त्याच्यामध्ये. सो पॉवर डेव्हलप्ड इन द आर्मेचर इज नथिंग बट EB इंटू IA. आपण जर तुम्ही जर पॉवर स्टेजेस लक्षात ठेवले असतील, पहिली स्टेज मेकॅनिकल पॉवर, पॉवर डेव्हलप्ड इन द आर्मेचर, and the C is nothing but output power. Output power चा formula in case of generator V into I होतं. Power developed in the armature EG into IA होतं. आणि मेकॅनिकल पॉवर दोन्ही पॉवरवरून आपण कॅल्क्युलेट करू शकतो आयर्न लॉस ऍड करून. ओके, आयर्न लॉस ऍड करू. जस्ट 1 मिनिट. हॅलो सर. हॅलो सर. Okay, see the power developed in the armature, it is equals to EB into IA from power stages, or you people already know the power developed in the armature, that is EB back EMF into armature current, that is electrical power developed in the armature of the DC machine. It is nothing but EB into IA. So this is the equation second. Now see, compare equation 1 and equation 2. ज्यावेळेस आपण इक्वेशन 1 आणि इक्वेशन 2 काय करतोय, कंपेअर करतो. कंपेअर इक्वेशन 1 अँड इक्वेशन 2. काय दिसतंय तुम्हाला कंपेअर केल्यानंतर? What about left hand side? Left hand side of the both equation, it will be equal. That means it is the power developed in the armature in the first equation. Also in the second equation, it is the power developed in the armature. If the left hand side of the both equation, it will be equal. What about right hand side? You people are very clever in the mathematics. Tell me, if the left hand side are equal, what about right hand side? Right hand side काय असते? See, left hand side is nothing but power developed in the armature. Equation 1 ची लेफ्ट हँड साइड आहे पॉवर डेव्हलप्ड इन द आर्मेचर, म्हणजे पॉवर आहे आर्मेचर मध्ये डेव्हलप होणारी. सेकंड इक्वेशन ची लेफ्ट हँड साइड आहे पॉवर डेव्हलप्ड इन द आर्मेचर. These two left hand side of the both equation are equal. That means right hand side also are also equal. Right hand side पण काय आहेत, इक्वल आहेत. So it is nothing but 2 pi n TA is equals to EB into IA. 2 pi n TA is equals to EB into IA. Okay. Now see, so this equation we will got. This is the third one equation. Now we know that the equation of back EMF equation का EB is equals to
P phi NT divided by 60.
Okay, see, that is phi P N Z divided by 60A. 60 कधी यूज करतो आपण? 60 कधी यूज करतोय? If the speed it can be taken in revolution per minute, we have taken the speed, it is in revolution per second. Revolution per second मध्ये घेतलेला आहे. So we are not using here 60. That is EB is equals to 5P NZ divided by A. Okay. So put this value of equation 4 in this equation 3. We will get one of the equation, that is 2 pi n TA. It is equals to EB ची value put करा 5P NZ divided by A into IA. Divided by A into IA. Okay. I want to find out the value of torque. मला टॉर्क ची व्हॅल्यू फाइंड करायची आहे, म्हणजे आर्मेचर टॉर्क TA फाइंड करायचं आहे. ऑल अदर व्हॅल्यू इट कॅन बी शिफ्टेड टू राइट हँड साइड. बाकीच्या व्हॅल्यू राइट हँड साइडला शिफ्ट करा. दॅट इज टॉर्क TA. इट इज इक्वल्स टू टॉर्क TA इज इक्वल्स टू 1/2 pi n into 5 p n z upon a into ia. So this n get cancel, n cancel झाला. Can I rub this? हे rub करू का मी?
Yes, sir.
n cancel झालेलं आहे. Torque equation, torque TA, it is equals to 1/2 pi into 5 p z ia divided by a. Okay, so what is the value of 1/2 pi? So this is the torque equation. हे जे derive केलेले torque equation आहे. 1/2 pi ची व्हॅल्यू किती येते बघा?
0.159.
0.159. Okay, so see, final answer 0.159 into 5 p z ia divided by a. It is the actual torque equation of the DC motor. It is in Newton meter. It is in the Newton meter. Okay, हे इक्वेशन लिहिलं तरी करेक्ट आहे, इथपर्यंत लिहिलं तरी पण करेक्ट आहे. 1/2 pi 5 p z ia upon a. It is in Newton meter. So this is the actual torque equation of the DC motor. This is the actual torque equation of the DC motor. That is, it is the armature torque equation of the DC motor. लक्षात आलं? सांगा याच्यामध्ये कोणाला काही प्रॉब्लेम? इज देयर एनी डाऊट? काय डाऊट आहे कोणाला?
No, sir.
Okay, so this is a very important derivation is there, and also it is easy. So from starting, first of all define torque, after that define the work done. After defining work done, calculate the work done in one revolution. एका revolution मधलं work done calculate करायचं. If there are n number of revolution, then calculate the power developed in n number of revolution. So this is the equation of output power. After calculating output power, we are able to calculate the torque equation, that is armature power developed in the armature. It is equals to 2 pi nt divided by 60 when the speed it can be taken in revolution per minute. If the speed it can be taken in revolution per second, then write only 2 pi nt. Then another one, electrical power developed in the armature. Armature मध्ये develop होणारी electrical power, formula for that is nothing but EB into IA. If we put the value of EB, that is back EMF, we just get the equation of torque, that is TA is equals to 1/2 pi 5 pz ia upon a, or 0.159 5 pz ia upon a. So according to this, torque TA is nothing but armature torque. Torque TA काय आहे? armature torque आहे 0.159. it is the constant. Phi is nothing but flux of the machine. P is nothing but number of poles of the machine. Z is nothing but total number of conductors of the machine. IA is nothing but armature current of the motor, and A is nothing but armature parallel path of the motor. So this is the torque TA is equals to 0.159 5 pz ia upon A. So this is the final or actual torque equation of DC motor. Getting? लक्षात आलं? हा, लक्षात आलं का? Hello.
Yes, sir.
Okay, so see, this one is important equation. याच्यावरून आपल्याला characteristics पण derive करायचे. For better solving the problem, I will tell alternate expression. एक दुसरे एक alternate expression आहे, ते पण मी तुम्हाला सांगून घेतो आता. So see, हे लिहून झाले ना तुमचं?
Yes, sir.
See, the torque equation again, हे इक्वेशन आहे, कन्सिडर करा. तुमच्याकडे या व्हॅल्यू नाहीयेत, फ्लक्स फाय ची नाहीये, पी ची नाही, झेड ची नाही, ए ची नाही. सो देन आय वांट टू ऑल्सो कॅल्क्युलेट द ईबी, सॉरी टॉर्क. सो डू यू नो दॅट द फॉर्म्युला फॉर ईबी इज इक्वल्स टू 5p(n)z divided by 60a. I want to tell alternate expression. Alternate expression किंवा दुसरे एक expression मी सांगतो. So see, if I calculate the value of 5p(n) divided by a, काय येईल व्हॅल्यू? That is, मला 5p(n) rearrange करतो इक्वेशन, 5p(n) divided by a याची व्हॅल्यू कॅल्क्युलेट करायचे. हे 60 लेफ्ट हँड साइडला मल्टिप्लाय मध्ये येईल, z डिवाइड मध्ये जाईल. सो दिस इक्वेशन बिकम्स eb into 60 डिवाइडेड बाय z. रिअरेंज केलं इक्वेशन मी फक्त बॅक ईएमएफ चं. 5p(n) डिवाइड बाय a एका साइडला घेतलं आणि eb into 60 डिवाइड बाय z एका साइडला घेतलं. ओके, सो सी, if we put this value eb into 60 divided by z in this equation, 5p(n) divided by a च्या ठिकाणी जर मी ही व्हॅल्यू पुट केली, करता येते का पुट? I will get the torque equation. TA is equals to 0.159 into 5pz, 5pn or 5pz, sorry, 5pz, here it is n. 5pz divided by a याच्या ठिकाणी मी व्हॅल्यू काय पुट करू शकतो? eb into 60 divided by n पुट करू शकतो का?
Yes, sir.
Okay, so I will put that eb into 60 divided by n. It can be putted instead of 5pz divided by a. So I will put here eb into 60 divided by n into ia. It is in Newton meter. So rearrange or just do the calculation of that equation. Equation rearrange करा किंवा simplify करा. Torque TA is equals to 0.159 into 60. किती येते व्हॅल्यू? किती येते? 0.159 into 60.
9.54.
9.55 into EB into IA divided by EN. बघा, तुमच्याकडे फ्लक्सची व्हॅल्यू नाहीये, एखाद्या प्रॉब्लेम मध्ये दिलेली नाहीये, पी ची व्हॅल्यू दिलेली नाही, झेड ची व्हॅल्यू दिलेली नाही, ए ची व्हॅल्यू दिलेली नाही. बट यू आर हॅव्हिंग द व्हॅल्यू ऑफ स्पीड. तुमच्याकडे एन ची व्हॅल्यू आहे, करंटची व्हॅल्यू आहे आणि रेजिस्टन्स दिलेले आहे. त्याच्यावरून तुम्ही ईबी कॅल्क्युलेट करू शकता. वन्स यू हॅव कॅल्क्युलेट द ईबी and by using this formula, that is torque TA is equals to 9.55 into EB into IA divided by N. From that formula you are able to calculate the torque equation, sorry, torque value. Okay, so this is also alternate expression. Both equation having an same result. यातलं कुठलंही इक्वेशन यूज केलं तर टॉर्कची व्हॅल्यू ही सेम येईल, because this is the alternate equation, or for our simplification we have using this equation. Getting लक्षात आलं? हा, लक्षात आलं का? याच्यामध्ये कोणाला काय डाऊट आहे? लिहिलेलं असेल तर लिहून घ्या. I will take attendance up to that. झालं?
Yes, sir.
Okay. So see, we are having 5 minutes. We will take one problem related to same equation. That means you are able to understand easily. All of you write first one problem. Calculate the value of torque established. Calculate the value of torque established by the armature of 4-pole motor having 774 conductor, 774 conductors, 2 paths in parallel, 24 milliweber flux per pole, when the total armature current is 50 ampere. Total armature current is 50 ampere. Tell me the given data. Read the problem carefully. It's very simple problem. Calculate the value of torque established. The torque established ची value calculate करायचे in the armature of the 4-pole motor having 774 conductor, 2 paths in parallel, 24 milliweber flux per pole, when the total armature current is 50 ampere. Tell me the given data. सांगा given data. Tell me given data. काय काय दिलेलं आहे?
P is equal to 4.
P is equals to 4. हा, next.
Z is equal to 774.
Speed is equals to का?
Z.
हा, Z is equals to 774. That means total number of conductor दिले आहेत. हा, next.
Phi is equal to 24 milliweber.
Phi is equals to 24 milliweber. We will convert it into Weber. काय येईल? 24 into 10 raised to milliweberचं कन्वर्जन वेबर मध्ये काय येतं? +2 -2 +3 -3 काय येतं? -3. So 10 raised to -3 वेबर. कन्वर्जन लक्षात आले पाहिजे तुमच्या. Once conversion it can be wrong, then your answer may get wrong. So 24 into 10 raised to -3 Weber. Again, what is given? काय दिले?
Ampere.
करंट दिले. IA is equals to 50 ampere. झालं? आणखी काय तर राहते बघा.
K is equal to 2. 2 paths in parallel.
2 path in parallel. That means A is equals to 2. Right? No? A is equals to 2 is given. And we want to calculate the torque established in the armature. That is TA is equals to question mark. So you people having the formula, तुम्हाला formula माहिती आहे already. TA is equals to 0.159 phi P Z IA divided by A. बघा व्हॅल्यू कोणते कोणते आहे तुमच्याकडे? IA ची आहे, A ची आहे, Z आहे, P आहे, phi आहे. Put the value and tell me the answer. That is torque TA. किती आहे ती व्हॅल्यू? पुट करा कॅल्शियम मध्ये डायरेक्ट.
Two 295.35.
295.35 unit
Newton meter.
Newton meter. So this is the right answer. That is armature torque developed or armature torque established in the armature. TA is equals to 295.35 Newton meter. Getting? लक्षात आलं? All of you getting torque equation and one problem related to that?
Yes, sir.
Okay. So
Yes, sir.
remaining problem we will take in the next lecture. In this way, we will conclude this today's lecture and we will stop here. Thank you.